Hi everyone, my name is Kevin. Welcome to my course, Using HTTP Client to Consume APIs in .NET Core. I'm a Microsoft MVP and a freelance solution architect, currently focused on APIs and security. In this course, we are going to learn how to integrate with an API from a .NET Core application. Some of the major topics that we will cover include creating, reading, updating and deleting resources, improving memory use and performance by working with streams and compression, using HTTP Client Factory for HTTP Client Instance Management, and writing custom HTTP message handlers. By the end of this course, you will have extensive knowledge on how to integrate with any API from a .NET Core application. Before beginning the course, you should be familiar with C#. I hope you'll join me on this journey to learn how to integrate with an API with the Using HTTP Client to Consume APIs in .NET Core course here at Pluralsight. Hi there, and welcome to the Using HTTP Client to Consume APIs in .NET Core course here at Pluralsight. I'm Kevin, and I'll guide you through it. We're starting the course by looking at the course prerequisites and tooling. Then we'll have a look at the supported platforms, frameworks and .NET standard versions. You'll notice that the current version of HTTP Client actually covers a lot more ground than just .NET Core, and that's thanks to .NET Standard. We'll introduce the demo application next, and we'll learn about different strategies for working with DTO model classes. Lastly, we'll learn how we can tackle integration with HTTP Client by having a look at its internals. If you happen to have any questions, the best place to post them is on the Discussions tab on the course page. I check this regularly, and like that, the questions and answers can help other people out as well. For very short questions that require a quick answer, you can contact me on Twitter. Or just follow me if you want to know about my upcoming courses, user group events, or are interested in the technology I'm interested in. I mainly tweet regarding ASP.NET Core, security, and APIs these days. Let's have a look at the course prerequisites and tooling. You don't need to know anything about integrating with an API. That's covered in this course. Knowledge of C#, however, is required. As we'll learn soon, what you will learn in this course can be applied to a variety of frameworks and application types, like an ASP.NET Core web app targeting .NET Core, a Xamarin app targeting Mono, an older ASP.NET MVC app targeting the full .NET framework, and so on. I will use .NET Core for my demos, so it can help to have some understanding of how a typical .NET Core app is structured. But it's not a requirement. The starter solution is already set up and well structured. It's not something we're going to have to dive into ourselves. Let's have a look at the tooling we'll use. We'll use Visual Studio 2017 for the demos in this course. You'll need at least version 15.3, as we'll use C# 7.1 in the demos. If you haven't got an MSDN license, you can download the free community edition at the provided link. But that doesn't mean you need Visual Studio 2017 to follow along. Any IDE that supports the framework version and/or application type you're working with can be used. Depending on your needs, that might be Visual Studio Code, Visual Studio for Mac, or other IDEs like JetBrains Rider. So, what are these framework versions and application types you can choose from then? Let's have a look. We will extensively use HTTP Client and the new HTTP Client Factory used to manage instances of HTTP Client throughout this course. Don't worry if these are new to you. We'll look into them in detail. We do, however, need to know the required dependencies for using these to be able to answer what platforms and application types you can use to benefit from this course. HTTP Client was released together with .NET 4.5 quite some time ago. It's thus widely supported across .NET Framework and related versions. Next to being included in .NET 4.5, it can be downloaded as a NuGet package. Let's have a look at the dependencies on the NuGet page. We see it's widely supported, notably on .NET Core, the full .NET Framework, and various .NET Standard versions, The HTTP client factory is quite new, released together with .NET Core 2.1. It's also available on NuGet. Let's have a look at the dependencies. Let's scroll down a bit. What's notable is the support for .NET Standard 2.0. That means that we can use it on any platform that implements .NET Standard 2.0 or higher. So, the lowest common denominator a platform needs to support these together is .NET Standard 2.0. If a platform supports .NET Standard 2.0, this means that we can also reference packages that require a lower level of the standard, because it's cumulative. At the moment of recording, the latest .NET Standard version is 2.0. But if a newer version is available when you're watching this course and your framework of choice supports that, you can also use that. Currently, the following platforms support .NET Standard 2.0. We've got .NET Core 2.0, which we can use for ASP.NET Core applications and console applications. But in the near future, when .NET Core 3.0 will be released, we will also be able to use it for building client apps. Then there's the .NET Framework 4.6.1 or higher, which translates to WinForms, WPF, ASP.NET Web Applications and so on. And lastly, the .NET Standard 2.0 is also supported on Mono, Xamarin.iOS, Xamarin.Mac, Xamarin.Android, and the Universal Windows platform. So, if you're working with any of these and you need to integrate with an API, this course is for you. That begs the question, what will we use during the demos to code all of this? Well, I figured that the best way to focus on HTTP client and related classes is to keep the rest of the required framework-specific knowledge as low as possible. So, we're going to integrate with an API from a console app. That console application targets .NET Core 2.0, the latest available version at the moment of recording. As we remember, that one implements the .NET Standard 2.0. As far as C# is concerned, we'll use version 7.1. In case you haven't got .NET Core installed on your machine, you can always find the latest version and any previous version via the link on screen. What we'll end up with after this course is a large set of samples and best practices, nicely separated, which can be used across platforms, frameworks, and application types. You can find the starter solution and the finished solutions for each module via the exercises tab on the course page. And if you prefer, you can get both the starter and finished solution via my GitHub. Let's have a look at that demo application. In this demo, we'll introduce the demo app we'll be working with. The solution consists of two projects, Movies.client, in which we will add our code, and Movies.api, an API that exposes movies. The API was built with ASP.NET Core 2.1 according to the best practices I've used in my other courses on building APIs with ASP.NET Core. But how the API was built isn't important to us. I created an API with ASP.NET Core as that's what I'm most comfortable with. But as far as our course is concerned, the API might as well have been built with Java, Node.js, or any other technology or framework. We will only very rarely have to change anything at that level. I added Swagger as well, so we can easily see what is and what isn't supported on our API. Let's build and run so we can have a look. Navigating to the API at root level opens the Swagger UI. We can see the supported resources and methods. We've got movies, posters, and trailers to work with. And if we scroll down a bit more, we can see the models. In order to keep the downloading of the exercise files under control, we don't use real trailers or posters for movies. These are just bytes generated on the fly. But that's sufficient for our purposes. For one thing, it'll allow us to create pretty big streams of data, which allows us to look into how we can optimize for that scenario. As an example, let's send a GET request to get the movies. We choose application.json as the response content type, we click try it out, and we click execute. And there we go. Here's a list of movies. In case you're wondering about the movies used as dummy data, I was born in 1981, So I grew up during the 90s, and these are a few of my favorite movies from that time period. So if you want to take a break from programming, check them out. And then there's the client. We're starting from a console app built with .NET Core. It targets the .NET Core SDK version 2.1, which is the latest one available at the moment of recording. The packages I already referenced allow dependency injection and logging to the console and debug output window. Additionally, since we'll be working with JSON a lot in this course, I also referenced Newtonsoft.json for JSON.NET and for one or two demos, Microsoft's XML serializer. Let's have a look at the implementation. It's a very basic implementation, but we don't need more than that. In the program class, I set up the IOC container, and I added a console and debug output logger. The integration service is what we'll be working with. Let's open that contract. It contains one method, run. Let's go back to the program class. When the application starts, we call run on that integration service. So it's in that method that we can write our code to integrate with the API. And to do that, we need to be able to make HTTP requests and capture the responses. And that's what we'll use the little gem called HTTP client for. If you look at the right of the screen, you see quite a few implementations of that integration service. The CRUD service is the first one we'll be working with. The other ones look exactly the same. I created one implementation per module. That avoids having one service with a huge amount of demos, and like that it's way easier to find the code you're looking for. One thing is missing though. We don't have client-side DTO classes yet. Let's see what our options are. A technique that's often used is creating a new project, say movies.shared. That would then contain the DTO classes. Both the client and the API reference this project. This diminishes code duplication and it ensures changes only have to be made in one place. It's also useful when you want to be able to deploy the model classes independently. A shared project results in an assembly, and that's a unit of deployment. So this is a good approach when you are in control of both the client and the API. And when both are built-in platforms that allow referencing the project. Another technique to diminish code duplication and ensure changes only have to be coded once is adding the DTO model classes in one project, say the API, and adding them as a linked file in the client project. This ensures that the files only exist in one place, the API project, but are packaged into the API and client assemblies when compiling. So there's no shared assembly. This is a good approach when you are in control of both the client and the API, and when both are built-in platforms targeting, for example, .NET Standard. So the code actually compiles on both platforms. But both of these techniques only work when you have full control over client and API. In a lot of scenarios, the API isn't built with .NET or .NET Core. It might be built with Node.js, for example. In other scenarios, the API is built with a .NET Standard implementing platform, but it's built by another team or company, and sharing a models assembly isn't an option. And in fact, it shouldn't matter in what technology the API is built in. I don't know with what technology Google builds their APIs, but I do need to be able to integrate with them. And that's what we're trying to mimic. This is a course on working with HTTP client, regardless of what technology the API is built with. So we can now do two things. We can simply look at the documentation and create client-side versions of the models, or we can use a tool to generate those. Let's look into that.